this video, we move to the last programming challenge, estimating the area of a circle for this chapter 5. So I put this picture here as an illustration. So the estimating is not because we all know is how to calculate the area of a circle. If you go to pi and the radius, you use pi times the radius squares, then that is the value of area. But for using these chapters knowledge is we learn the size, we learn the probability. Within this statistic context, we can try to use this R square dot this board. Then is the point is like you throw a dot to the board is if this target is within this dark gray area is our circle. Then this we see that it's inside the circle, and if that's not in is in these four corners, then that's outside the circle. So if you keep increasing the number of darts, or we call that experiment, then we can use this statistic way to try to simulate or try to approach the areas of circle. And we can see when we have more and more large the sample base, how closer we go to the real the area, the result of a circle. So that is a way that we can use the if you don't know the formula to calculate the area of circle, this is a way that you can use the more and more experiment to find out the pattern. And also, once we make these are the tools on hand, is we can even use this to estimate pi. So we know pi is 3.1415, but how we can validate that together. So let's look at here. So remember this one. So we have the center of circle in the middle of this square. And within the discussion, this we later on you will see. So we will use the left bottom corner this as the origin point. So please put in mind this is the 0, 0 in x and y. And if we have the r as the radius, the center of the our board will be the x equal to r, y equal to r. So the coordinate will be r, and this point will be 2r, 2r. And here is the r, 2r. So that put that in mind, and later on you can see the formulas we may use. And consider that that pictures the figure 5, 6. So let's back to the 5, 6. So let's see. This is our 5, 6. So we use this to estimate the area of a circle. So we put this n. Let's make some the formula, this definition for the variables. The heat, some of these will heat the board within the circle. Then we see that is a n number. Others miss. So outside is this 4 will be m. So if we consider the fraction of darts that land inside the circle, then this f is the probability. So n divided by n plus m. N plus m is the total sample space. Then the variable f, or value f times a is the area of the square, would roughly be equal to the square's area. So this is our principle or our logic to try to approaching the area of circle. And the actual area definitely will be pi r squares, and we will use that to compare how close we will do. So as part of the challenges, we need to write the program, find the estimated, this is the estimated circle, given the numbers of the darts and given the NA radius. So if we can read a radius is 2, then you throw 1,000 darts was the estimated area through our logic, and this is the theoretical the area logic of the circle, and we can put this more and more this estimation to see whether we are closer to 12,566. So you can see here is maybe here is the more far away, but if we have a pattern, so let's see whether that can be the closer, and we may also consider is to plotting that to have a look. So that is our the target. And then this we will define our just use this function random uniform AB. So that is a built-in function which will return a random number between A and B. So this we will use that to simulate the dart position. So as I mentioned, is we put here is a 0, then this we can put A is a 0 and B is a double R. So then this if we generate R, there is a random for both either X and Y, then this X and Y will represent as a tuple to this coordinate on whole square. Then that will be our the estimated the logic. And once we finish this, we will go to see how we can extend our program to estimate the value of pi. So that is also interesting part. So let's starting to make our code. So 05, 03 now is the last one. Is the let's see. So it's the 5. Let's make that 1. So estimate area of circle dot p1. So here is I have some the naming. So this naming should be 3, 4, 1. Yeah, should be this one, and this should be 3. Yeah. Yeah, I will. So that this will be the correct ordering. So let's go to our file. So first is this one. Let's see, is to estimate the area of given circle R. So that is the thing. So we will define our program. Is the program is we just let's see. So the key mean program to see what we will achieve. So the first is we should ask a user to give our reader. So readers is should be a float, so not our integer. So input and enter the reader of circle. And is once we have the reader, is we can calculate the theoretical this area. So area of circle is equal to is the pi times radius and with this one. So we have this, but we should, if you want to use pi, you should import mass, and also we should have mass this module as the prefix. Then we can see as the print area. Print is we see the area. Okay, area. Let's print is the radius. 0.2f. I think maybe it's let's make us larger, and the area in theory. Let's give 5f as well. Dot format, and we go this radius and areas. So let's make a run. So if I got 2, so I got similar like here. So it's 1, 12, 5, 6, 6, 3, 7. So then it's you can have maybe 6 is they always have that the calculated. So first is we have our the foundation to make. Then is what we will do is we will try to make the those how many times of this this estimated. So then is we what we will do is we will create our estimated this the function. So let's put that as estimate. So def estimate. So estimate. Let's see what we need to the input as the arguments. So first is we should let the program know how large of this the board. So this board is actually is the 2r times 2r. So radius should be one of the argument which will transfer, and also the total. The points should be the transferred. So the total point is we can send that as our list. So total points. So later on, I will show you is how we can make this into the plotting. But for now, just for this total point. So for this sample, so we only have this 3. So we put this as a list: 1,000, 100,000, million. So that is our list. Then we send that to here. So we will make this the estimate for our current. So let's see. So we call this estimate with the radius total point. So total point, bear in mind, is our list. So what we will do is we will put that as the one by one through this for loop. So first is let's decide our center of this board. So center actually is just our tuple. So our coordinate we will define as the tuple. So as I explained this. Is the R and R. So we put this first element is X axis, and this is Y value. So we put this in circle. Define is in circle the initial. The check is you can use true false, but we will count that. Then we will use integer. So in circle is 0. Out of circle is the y, then we can calculate that. So for I in range, what is the total point? So that means it's in this 3. The point is we will use the random. So if we starting to make random, is let's also import random module of the library. So X is random. We use that there's a uniform, which is the uniform distribution from 0 to 2 times radius. So same as we got Y. So sorry. Oh. Now we have this x and y, and we will package them into one tuple, x and y, as this point. So we can start to check is if we have a point here, whether it's inside the circle. So inside the circle means because it's a circle, so the boundary, the distance to the center will be r. So we can calculate this distance to this center of the circle, whether it's more than r or less than r. Even it's right on the r's this circle, we can count that is in circle. So as long as we know here and this x and y, actually bear in mind is x is actually is a point to here. So this is the origin. So if you want to calculate this lines, you need to know this x relative to this r, so you need to deduct the r and then use this triangle formula to calculate. So that is the ways I define this distance as d. So d will be the square root. So we already have this mass, so we can directly use this square root, this formula or function. Then that we should have this x squared plus y squared. Then this the square roots will be these lines. So how this x is we use this x random. So we should have the one parenthesis x minus now x is not the yeah, now x we should use this p tuple. So we should use this p0. Then that's the first element minus the center. We define the center is here. So center 0. Now we get this length, and we will make that as r squares 2 plus p1 minus center 1, and then squares 2, then square root. So this is this distance. Then we have this distance. What we can do is just our if check. If d minus radius. So what we will see, then that will be in circle. So in circle is initial is 0, then it's in circle equal to in. Let's use this more clear way. So you can definitely use the in circle. So can be in circle plus 0, 1. So plus equal 1. So that is the equivalent the syntax. Then we have that is once we have 1000 finished, then we know how many in circle. Then this for loop is done. And we have this for loop for the 3 these areas. So then this we can see is we have our the in range is the in circle we count for this total point. Then this we will do this area. So area is square is we can put that as the here. So area is already here, I think. So we have the area circle, so we don't need to calculate that again. So, but this one is the radius. We can use. Let's see. So we can use this directly area of circle. From the outside, I think. And then this what we will do is return for I. Let's see how many we return for I in this one. So in range total. So well, we should total should be the just the transfer this number. So we have this total points. So let's make this. So we only need to transfer 1 point. So if the 4 point in total points. So every time we transfer 1, so total point. So we transfer the points here. And then this what we will use. This will be returned. So and once we have this done, then we'll return this. Let's see. So return our total points. We will return that divided by this area. So let's make this put in here. So let's see whether we need that again, or we can directly use this. So in circle is our count, and that is divided by total point. And then times the area of circle. So this is already in our primary parts. I suppose this will be okay to use. Then I return these areas. So then let's here. So directly I can print. Print the thing is I don't need to print this area again. I just need to print this estimated. How many? So these are 0. The points starts with 1. Let's make that dot 5f, and the format. So that is our first result, and we also need these points as our another one. So let's count. So radius points was never closed. So line 33. So let's go to our line 33. Print. This, so missing one, I think. Well, we have this one, then this here. Oh, yeah, now I closed that. Okay, let's put 2. So estimate that is, but the result is not correct. So area of circle. So area of circle is pi times radius. Radius is 2. So divided by total point is y is only 9. So in circle is in circle plus 1. Let's put this 2 times. Let's run this again. So look like it's only around 9. So if I put this quite big, it's 10. So maybe it's just the areas this estimating, but it should be 12 around. So I must have some the difference to send. So I sent this 100,000 put in here. So I read this, and then in range, and here is the 2. We can later on is type this one as the debug, and the P is our X and Y. here, let's see whether here we did correct. So P0 minus center times 2, and then this P1 minus center 1 square 2, and use this mass square roots. So we count this whether it's minus less than circle. So if yes, then we increase this. And this in circle, these are the total point we transferred. So if we transfer 1000, here is the 1000. Here, this one. Possible is this one. Do we need to? Yeah. Let's stop this. It's too big. So I think it's maybe we should do this again here. So let me try. So still not go to that closer. So then that means this one is not relevant. So radius, do we have any radius here? Format is radius is enter the radius 2, and area is this one. Oh, I got the 2 points. One is the here I missed this equal. So first is the if this dart target is go to just the boundary, the edge of the radius. I missed the count that. I just use less than, should be less than the equal. And secondly is this one. I think it's I should is that here is the square, not the. So we need to times this as the squares. Then let's make that larger. So the square is just the radius times 2 times radius, then square 2. So that is the actually is decided the go to this the ratio. So now is the result is perfect. So try to see here is we need to use this area to compare. So compare is this is our number of the points, and these are the total the areas. So not this area of circle. So I only use that one. So this now you can see is quite close to that. Let's make that plotting something. So we save this and we make our the additional one and do our plotting to see. And plotting, if we want to do the plotting, is let's import the mat days dot py plot as plt. So we need some list. So one list will be our total point. Second list will be the days result of our target. Then we see is how they can approach into those. So for those, let's make our total point adjustment is a range. Let's see we just go to 1 to 1000. Then is we have our this one, and once we have this estimated, then we will have is our x the points axis is equal to this, and estimated let's use s is also just like this. So for point of this one, so we will do the points axis is dot append points with the point. And once we have this one, we will have just estimated access is append with our this. So we put that as x estimate is equal to this. And we have this one put in here. Then we don't need to code double times. So then we have our two list. Then we will draw this two list. So plot so is the one is this one. So put that as x. Put this as y. And let's show. So I just up to the 1000, so not give, and let's give 2. So estimate float object is not collapsible. So the estimate is this one. So estimates result. So I used duplicate names. Okay, so now you can see here we calculate 1000 times, and if I make that larger, so it's approaching to this 12 something. So first is getting the up and down quite big, but now it's getting this. So you can also draw this mathematical the area of circle line here. So putting that in the same the line, then you can closer to see how that will be the making the this difference. So let's comment this don't let this print, and I put this 10 times more. So let's run this with 2. Just wait seconds, then it should draw that because now it's getting the longer to do the calculation. I hope it's getting while waiting. So we will use the next part, the formula to estimate the pi. So you can see here is the area of square is 4r square, and the area of inscribed circle is pi r square. So then if we use this divided by this, or this circle square divided by this, then we got pi fourth. Then this we times 4, then we get pi. So through this way, so we can also try to validate what are the estimated value of pi. So it's just a little bit customized of our current program. And left is already nice, is you can see. If we go to the 10,000, it's also getting more and more stable. So you can also see the here in the left is like days huge, then it's getting slower when they smaller when they move to here. So that is a way so you can also use this visualized approach to validate your the calculation. I leave this second one for you, so you can make this yourself reference. Then let's back to the first one and rename this to 3. So and then we will use this to estimate pi value. So the value of pi. So let's see what we have done here. So we don't have the reader. I think it's reader. We if we want to divide it, I think it's the most the easier way. So we set reader is 1. because 1 square is still 1, then it's just 4, and here is pi. So that is the easier. So we don't need to give these radius parts. So let's remove this one. And then this people doesn't need to call this one. So when we see the format is radius is just let's see. So the estimated the area of circle is just mass pi. So because here is 1, and we don't need to call that. Let's give the radius is just 1. So we decide that is a radius 1, center is still needed, and we have our areas is just 4. So you can consider, and in circle is 0. Then for I in range, we give this total point, and we give this x, y, p, d, all the same. Then what we return here is the in circle total and this area. So we still use this area, but now area is also just 2 times 2, 1, and the square is 4. So this one we don't need to change that, but we return our this ratio, and this ratio is actually as our formula. It's just the pi minus divided by 4. So then for points of here, so we don't need to the print. We can print a radius. So area. So that is no need. We do here. So total point we decide, and then this known value. So what we print is the let's see. So estimate and the known value. So estimate known pi value is 1. So we can just put that as the mass pi. So that is our known value. And estimated value. So estimated pi is this one. So format is what we will call estimated. We call that is just give the points to them. Then that is our estimated. So let's have a look. So you can see here, 100 is estimated. That should be mass.pi. So let's see here is 315,14159. So here is 1000 is 307, and here is 15 is already close, and here. So let me give another just 10 million. Yeah. So let's see how much it will be calculated. It's have some more seconds, but we'll see. You can see it's 190 is a little closer, but that is up and down because the 10,000 is already more closer. So 13, 19, 14. We should go to this 1415. That is estimated. So now that just give you another way is you can try to use some this estimated approach to validate some the mathematical values. So I hope you understand these 3 the demos, and we start is let's back to our mind map. So then is we finish this area of circle estimation, and after that is we also finish the whole chapter 5. So again, congratulations for you to follow with my the video and finish another chapter. And as usual, is same as the earlier I mentioned is I have put all the code, the program name, and linking to the mind map branch, so that you can refer to the GitHub, then get this cross reference. So I will add this number 5 and correct this naming after this video. And then after we close this one, we have only 2 chapters ahead. So the next chapter we will back to some geometry parts to do some drawings. So in the last 2 chapters, we very focus on the calculation, not too much of the drawing, but I add some additional the hints for you is if you have numbers of the lists of the sample data you can draw and to try to make the data visualize to you. That will be the easier for you to do the analysis. It's an old saying is one picture is more value than 1,000 words or 1,000 sentences. So try to think about how you can visualize your data. And the next chapter, we will have draw geometric shapes with some additional patch of our library learned. And we will draw this. This is a very interesting fractal. So, and then we have a 4 challenge. After this one, we will move to some a little more advanced mathematical in the last chapter is on the calculus, the problems. You see here is quite a lot sub-chapter, but that is maybe it's the senior, the high school, or the go to this college. You need such kind of those weapons using Python. So after all, thank you for your interest. Please follow my channel and give me your comments, and looking forward to see you in the chapter 6. Bye for now.